Hi guys, I want to introduce you to an LLM which can check for hallucinations. So let's say you have a RAG implementation, you have a document which has been uploaded as a knowledge base, your LLM spits out a reply based on a prompt, and then you just wonder if the output that the LLM gave you is correct or incorrect, or what percentage can you rely on the LLM to provide you that specific output from the reference document that you have uploaded. Now in this channel we have talked about RAG systems, and there are so many different implementations of RAG, but how do you know if the output is correct? So I want to introduce you to Bespoke-MiniCheck. That's an LLM. It's available in Ollama, and we are going to check it out, how to get the installation and everything. But this is a state-of-the-art fact-checking model developed by Bespoke Labs. Now, Bespoke Labs, it's an amazing organization that is trying to combat hallucinations with the state-of-the-art grounded factuality model and APIs. So we have APIs available. We have the implementation on Hugging Face as well, but we are going to go and have a look on the playground. But before that, we want to understand the model itself. Now, Bespoke-MiniCheck, this is a state-of-the-art fact-checking model. It's a 7 billion parameter model. It's a small model, but don't be concerned about the size because it performs very good, and it's comparable to the open source models as well. Now, Bespoke Labs, this is a grounded factuality checking model developed by Bespoke Labs, and the model takes in input as a document or text, okay, and a sentence, and the sentence is the output of an LLM, let's say, and it determines whether the sentence is supported by the document. So in the implementation phase, we have the document, for example, the RAG documents that we can paste here. If the length of the documents is within 32k tokens, then you can put the entire document. Otherwise, you have to go for chunking. So we put in the document, we get the output from a different LLM, and now we paste both these things, the document and the claim or the output of the LLM itself, and put it to Bespoke-MiniCheck LLM. This is a different LLM, and then it spits out a yes or a no. So let's go through this example. So if the document says the students are preparing for the examination, so imagine this, the students are preparing for the examination. That is the document, that is the RAG document, that is the knowledge base. Now the LLM spits out the students are studying, of course, and we get a yes here. Converse to that, you can see that if we say that the students are preparing for the examination, and we get the output as the students are on vacation, and we pass both these things. Now it's illogical, because if the students are preparing for the examination, they cannot be on vacation. So this model spits out a no. How cool is that? So we have the RAG documents, we have the answer, and now we can pass both the documents and the answer through a different LLM and get the output as a yes or no, so as to increase the confidence on the answers. Because up till now we have to just pray that the model picks up correctly on the documents. So how to use this? We can use this. This is the prompt template. We just paste in the document, semicolon, and put in the text here, claim, and just put in the text here. The response will be either in yes or a no. Let's check this out. So we go to Ollama, and we go to models here. This is a very new model, so we go to the newest here, and we go to Bespoke-MiniCheck. Then we'll be diverted to here, and then we can go and copy this Ollama run. But before that, on the Ollama itself, we need to have Ollama installation. Now we can click on download here and download for Windows. I have already downloaded for my Windows, so I am going to go to my CMD here, and in the CMD I'm going to paste this Ollama run Bespoke-MiniCheck and just press enter. So this is going to fetch the model if it is not available in your local system, but I have the model already downloaded, so I get this ready and I can just put in questions to that. So let's take an example. Let's take this prompt. The document is a group of students are gathered in a school library to study for the upcoming examination, and the claim is that the students are preparing for an examination. What do you think? Is it a yes or a no? Let's press enter, and you can see that that's a yes. Another example is the same document, but the claim is that the students are on vacation, and I should get a no here. So that is pretty cool. So this is the performance of the model. We can see that it is even being compared with GPT-4o, and it performs better. So you can see the average on all these benchmarks. We can see that Bespoke-MiniCheck stands on the top when we calculate the average. The performance of this model is evaluated on the new benchmark known as LLM-AggreFact. So this is a new benchmark which used 7 or 11 recent human annotated datasets on fact-checking and grounding LLMs. So Bespoke-MiniCheck 7 billion is a fact-checking model. Despite its small size, it is comparable to GPT-4o and big models, for example Claude 3.5 Sonnet, Mistral Large, and Ollama 3.1. So those are all the good models, and the results are comparable. Now at this point of time, if we talk about the cost associated, you can think, how much does it cost for GPT-4o to generate some things? And on top of that, if you go on checking the answers with a yes or a no, then it would cost so much. But Bespoke-MiniCheck 7b, it's open source. Basically it costs 400 times less than GPT-4o, and that is huge. Now we have the paper here. I will paste in a link to the paper. You can have a read. Now let's go. We have the Hugging Face implementation as well. You can go down and you can see the simple implementation, pip install, and then you can use this. You can use a model here, and you can put in the doc here and the claims 1 and 2, and you can check for different answers, and you can use it in your use case. But for now, let me go ahead and discuss a little bit about the grounded factuality. So grounded factuality is a way of measuring hallucinations. We don't want our LLMs to hallucinate, and we don't even know if they're hallucinating. So this method by Bespoke Labs is a very good way and a very cheap way to understand if your model is hallucinating or not. So the factuality of a claim is checked with respect to the given context. The problem is also called textual entailment in the NLP and linguistic literature. Now, grounded factuality is extremely important for RAG, as we've already discussed, where the context naturally exists and the LLM generate claims answers. If the claim is not factually grounded in a context, so that's the grounded factuality. If the claim, or which is the answer generated by the LLM, is not factually grounded on the context, if it's not relevant to the docs that you have uploaded, if my RAG system is not operating correctly, it's a very bad system. Okay, and you can see that Stanford study found that in a legal setting, RAG-based AI research hallucinates 70 to 33% of the time, contrary to claims that RAG systems are hallucination-free. You might have seen, and I've seen myself, that RAG systems are not hallucination-free because it actually depends on the model, and it's an LLM. It can hallucinate because it is based on hallucination. We started the LLM. We wanted the LLM to hallucinate. We wanted the LLM to create a story. So that was the purpose of the LLM. But now we want our LLM to be rigid and to have good answers based on the documents that we have uploaded. But anyway, that's for another time. But now let's go to this playground and check out some interesting things. So what I've written here is a context. Let's say Michael is a coder who codes all night. Today, he is in Paris for a meeting with his wife and kids. Now they're having dinner at a restaurant. Okay, so imagine this incident, and I can say today Michael is on vacation. And this claim is only 32% likely because nowhere it is mentioned that he is on vacation. He's a coder. He could be for he is not on vacation, first of all, because he is in Paris for a meeting. Now if you remove this meeting, then from 30% we have 59% likely that a claim is supported by the context, which means it's 59% likely that he is on vacation. If I use the word vacation, let's say he's in Paris for fun maybe, then we can see that it is increased to 81%. And let's say if I use the word vacation itself, then it's 94. Cool. Let's say he's in Paris for meeting up with a friend. That's 40% likely for a vacation, let's say. And again, we can increase this. So you can see how it is constantly related, and it's taking the input from the context. It's keeping the context as a reference, and the output that is generated from the LLM as the claim, and it's trying to understand if the claim is supported by the context. So this is an amazing model. It's a cheap model, but this is the model that we want to integrate or keep it at the end of your pipeline for any applications that you make. So from now on, I think we need to keep this model at the back of our RAG pipeline. And this is an interesting model. You can see the LLM aggregate leaderboard. So here we have already seen that it's performing very good when compared to the average. And take a look at the leaderboard for grounded factuality. And this is the model, and this is the dataset that has been used, and you can have a read of the dataset how this is done. And that's it. I think this is pretty great. I am going to use it regularly, and I think you are going to love this too. So try it out, ask any questions if you had, and I will see you next time. Please subscribe.